Well, it's that time of year again where I realized that I put the wrong lens on my camera and you can barely see what's going on here. So this bike here is one I bought back in February. It's called a Flevo Bike Basic. It's a very old bike. These were sold up to, I believe, 2001 or 2002. Part of kind of a recumbent bike craze in the Netherlands. Craze. They sold a couple thousand or something. It was back then a quote-unquote cheap recumbent bike, still over €1,000. I bought this because it was €100 and I wanted to try out to convert a recumbent bike to electric. Now back in January, February, I used to have my upright electric bike. Long story short, I kind of wanted to change that over to this bike. So you can see it has a decently large rear wheel. It's 26 instead of 28 inch, but relatively easy to convert. And it's also a pinion drive. And so I thought, well, it's basically just an easy swap. Just rebuild the back wheel, swap it out, and within like an evening, I could have this bike electric. So I even did some preparatory work. I installed the pedal assist sensor, and that didn't work out, and it didn't work out for a pretty catastrophic reason. Namely, I wanted to change out the pinion. For some reason, it was completely seized up. When I would try to remove it, I broke the motor, like physically ripped out the whole side of the motor. Let's try to find another motor, and I did, but unfortunately that one was pretty defective. I did not bother to check whether it was running right because the motor looked very good and it was from a working bike, but it ran like absolute shit, like way too much resistance, so it was a total failure. So I went and got my third motor, and that's where we are today. So here's the third motor. It's an 8-fun. The brushless motor for e-bike. Oh, it actually says that on the rim, if you can see that. Total bullshit, of course. This is one of many cheap Chinese brushless motors, and I found out a lot about electric motors for bikes. So this is the last thing I'll say before we dive into the actual motor. These motors are not direct drive motors. They're little outrunner brushless DC motors inside, like what you find in radio controlled toys, like airplanes and that kind of stuff. Those drive a planetary gear system, and that's actually connected to the outside shell. So the inside motor runs quite a bit faster and has some gearing, so it makes some noise while riding, which is not that much of a problem for me. But a lot of Chinese bikes or Chinese bike motors apparently have plastic gearing, and when the motor gets hot and when you put it away hot, these gears can deform and just seize up the entire motor. It boggles the mind why they do this. Anyway, this motor does not have the problem. It has proper metal gearing. We will not be tearing down this motor, but in a future video, we'll be tearing down the motor inside that there 20-inch wheel, which was the previous motor, right in the back. You're not actually able to see the hub. Whoops, I lied. There's actually another part to the saga, and that is this controller. This is the second brushless controller that I bought. It's really a train wreck of failures, this project. I bought this one because the previous one that I bought apparently required Hall sensors to be built into the motor, and I did not feel like hacking something together, so had to buy another one. Rookie mistakes all around. So anyway, here is one of the old batteries from my ex-electric bike. Here's the controller, and here is the motor, and if I rotate this speed control knob, then at some point, yes, there it goes. It starts up, goes at about 5-ish rotations per second, and it does actually modulate to quite low speeds. So here is the quote-unquote old, well, second motor, which as you can see I have dremeled open almost completely, and I do intend to actually show you the inner workings of this, but yeah, there is no non-destructive way to do that. We'll do that in a later video. Fortunately, this size is almost identical to that. The pitch circle, so the distance between the holes, is only 9 millimeters different. It's slightly wider, but that all should mean that I can probably use the exact same spokes and this rim to replace this. So it saves me a lot of time on redoing the spokes. Well, there we go, all laced up. It was actually pretty simple because it's just a one cross pattern. So there's very little post tightening to do, and it exactly fit with these spokes, so I'm pretty happy with that. So next up, putting it there. Alright, well, it's on, and unfortunately, even though it did have disc brake holes on it, I had to remove the disc brake, so my front wheel is now brakeless. It just quite didn't fit. The brake disc spacing was I think this is 11 millimeters, and the original spacing was 15 millimeters. It's exactly 4 millimeters off. This is a problem, obviously, because electric bike, especially a fast bike with just one brake, isn't going to cut it. And also that there brake, let me see if I can focus. Yeah, it's impossible to see. There's a brake there. It's an old pull-up design. Those don't brake very well. So what I'm going to do is change that to a direct pull caliper, so I at least have a decent amount of braking, and I will limit the speed of the motor to like 20 kilometers an hour or something. I can use electric braking, which is supposed to be an option on this controller. By the way, it does work. And should go anytime now. There we go. Alright, well, it's pretty much all done now. The bike, well, there's the front wheel with the motor, and the controller is mounted there, under the seat, and then there is on an extension cable is the battery here. Unfortunately, the speed control is still the potentiometer. I'm gonna take it out for a ride and try to get to rev space to increase the battery capacity and bump up the voltage slightly, because it is a little bit meager right now. Well, I am back from rev space. I've built a bigger battery, higher voltage. On the way there, the speed of the motor loaded was just about 18 kilometers an hour, and on the way back it was almost bang on 25 kilometers an hour. Now that I'm back, I've tweaked some things, removed some wires from the motor, and went to try it out, and it wouldn't start. So I opened up the controller, and I guess this is as good time as any to have a look at the controller on the inside. So this is how these Chinese motor controllers generally look on the inside. They are all extremely similar, and in a next video I will have a more in-depth look at a larger controller than my previous controller. This is a 350 watt 36/48 volt controller, and as you can see here, there are 6 MOSFETs. These 6 MOSFETs, they are actually half bridges that go to the phases of the motor. So 1, 2, 3 phase wires. And then there is another MOSFET which does stuff. I'm not 100% sure. E to the pi I plus 1 equals 0 that's the blog to go to find this stuff in excruciating detail. Now, one common characteristic of all these controllers is that the controllers are absolutely chock full of wires, and this one I've removed many wires. Like this wire here I just cut off and heat shrunk just to get them out of the way on the outside. There were many more wires inside, like it was pretty much impossible to see the PCB here. All these wires, they have different functions, and some controllers are sold as having a, you can see here, little dot that says CCW, that's counterclockwise. So if you would connect that wire, I'm pretty damn sure that you would be able to rotate this motor in reverse. Same goes for a couple of other ones. What can I see? EBS. So I believe, I'm not quite sure. I think that's a braking system thing. I think the MSP one, that's for a cruise control. And there's a 1-to-1 right here. Not quite sure. As well as this O3. Really no idea. So DMS, this is the lockout feature, goes to both the anti-theft wires that they install as standard on all these units and the actual on wire, and as you can see, I loop this to the input voltage so that when the battery is connected, this unit is always on, just one less wire to worry about. What I particularly like about these units is they all have these silicone rubber gaskets that everything goes through. These seem to be mass-produced like this. This is a extremely cheap way to lead your wires out without like having to pre-mold something. Although, to be honest, it's not great, because like the proper way to make these gaskets, if you would have a proper gasket, it would be molded in such a way that there's like a flimsy bit of, like the hole that these wires punch through has just a flimsy bit of silicone still on it, so that the wires, when you poke them through, they get like enveloped to pretty much a watertight seal around the wire. Now, unfortunately, on these gaskets, that is not quite the case. It's very hard to show this handheld, but as you may be able to tell, like they didn't do that good of a job. Most of the wires, like I've removed a couple of wires, but some of these holes were already like full-on holes. Nothing holding any water ingress back, so kind of shitty. I mean, what do you expect? By the way, this controller was $15 delivered. I cannot believe this. So the brain box of this operation is this STM6S or 8S. These are like dedicated BLDC motor controller devices. You find them in all of these. This may actually be a genuine ST part. I don't know. ST does make pretty cheap motor controllers, but it has so many functions. I think it's like a microcontroller with BLDC or some kind of BLDC peripheral. I don't know. And for current limiting, they do current limiting, like proper current limiting. They have this shunt here. It has a big solder blob on it. I'm not sure if that is to calibrate the actual resistor or if it's just a solder blob. Now, of course, the input cap is a complete no-name brand, 63 volts, 1000 microfarads. I would be replacing this. The MOSFET's exactly the same as on the block. I will link you that block. It's awesome. And otherwise, yeah, you can see the something I really like. I'm not sure if this conveys well to people who aren't in power electronics, but like all the gate drive is done discretely. So with, I think those aren't even like little MOSFETs. I think they're BJTs and resistors and capacitors, and it's just like it's an RCD plus transistor drive. It's incredible that you can get like decent performance. You are driving like a 350 watt motor with this, and it does actually output decent power. I think it's more than 350 watt peak. So I'm amazed. at like the low cost, because it's just this chip, and then everything else is very cheap passives, and yeah, nothing that's particularly expensive. I can imagine this being built like in bulk for $15, no problem. Now the mounting, there is a thermal grease, and this goes into aluminum box with only Chinese on here, although it doesn't really, like, everything you need to know, it's on there. It's like the under voltage limits and nominal voltage, and then phase angle for if you use the Hall sensors. I obviously desoldered that connector. By the way, this is super thin aluminum. This will not actually conduct heat away to the entire enclosure. And then the end plates are, of course, just punched and dressed steel with rust, as you would expect. And that's pretty much it for these controllers. But what I wanted to show you is that for some reason this wire came loose, one of the motor wires, and by the looks of it, it was never properly soldered. So what I'm going to do is redo the solder joints on all the power connections, because yeah, I mean, this is what you get for the money, of course. And this here beast is now the battery. It's gotten an extra layer. It's now 3 batteries thick. It's a 12 series, 6 parallel, so a total of 72 cells for about, let's round it down to 650 watt hours. Now I did go from Restways to my house, which is about 14 kilometers, and it used up, well, it went from 50.5 to 49 volts, so that is pretty much nothing. It used 10, maybe 15%. So I do really think that it shouldn't be too hard to get close to 100 kilometers, maybe 80 kilometers out of this battery at at full power. So I'm pretty happy with that, because so this motor is definitely a lot more efficient than the previous brushed motor. So this, like, that kind of goes to show, like, it's normal for brushless motors to be like significantly more efficient. Now, this is certainly not the last you will see of this project. I fully intend to refurbish this bike. The bike, like, it has a little extension tube, which is actually part of a car exhaust. It perfectly fits, so if it fits. The seat is also, it's a very worn down wooden seat. I put a mat on it. But yeah, it's not the best. I intend to get the original seat on there, and well, the decals, you can see a little bit of the decals there, a little bit of yellowish stuff. It says basic there. I have contacted the manufacturer and hope to get like the proper decals for that, and everything else. Like in the rear, it uses a now defunct 3-speed internal gear hub and sprockets, and I will be replacing that with a fully internally geared hub, and getting rid of this chain situation, maybe making it enclosed. Basically, this whole bike will be pimped over time. But for now, I have an electric bike again that I can use for easy commutes and longer distances. So I hope you enjoyed this video, and I hope to make a video about my e-bike very soon again to show you the other controller and all kinds of other cool stuff.